This video is the second of 4 videos on marine electrical systems. Those who follow our channel know that we made the decision to haul out BioTrek and winterize the boat with antifreeze in preparation for New England winter. We're now in Canada in our compulsory 14-day quarantine, and we're staying in an Airbnb near Peterborough to be close to my father when quarantine's finished. This video is one of a series of videos on electrical systems and BioTrek, and there's a menu in the comments section if you want to skip ahead to a certain section.
Welcome to BioTrek Sailing, and in this video we're going to be talking about batteries, all about batteries. So why don't you tell the viewers about why you know so much about batteries?
I get the label of a certain level of expertise in a lot of field, and some of it is learned at school, but some of it is also learned on the road like so many of us. And I was reading recently a description of what an expert is. And I think what best defines it is an expert is somebody that really knows what he knows and also knows what he doesn't know. And if he doesn't know something, he knows where to get it. On a more serious note, on my background part of things, I started flying when I was 14 years old, and later on, of course, became an airline pilot. But on the sailing part, I started sailing, even earlier on small dinghies. And then that grew into getting up to the Olympic level for 14 years in the Canadian Olympic team.
In tornadoes.
Finished on tornadoes, yeah, but that was a transition up. What ties all of this back to the boat systems, as you mentioned, and electrical system to be more precise, is most of my background in parallel to those two things like flying aircrafts and sailing was my interest in computer science. So when the first IBM PC came out in the early 80s, I was extremely interested. I bought one of the first PCs, and I very quickly became a hacker in the good sense of the word at the time. Things have changed since. And of course, started to learn at machine language level because that's all you could do at the time, which gave me a very good idea about the operating system of the PC and all the power that as an assembler programmer can have on chips. So that grew quite large, and as far as expertise, doing contracts for the large manufacturers, up to a point where I just needed more formal knowledge. And so I went back to university, and this time I specialized in mainframe operating systems. So I thought that working on mainframes on one hand and the PCs on the other at the time was quite rare, and it became very valuable into my understanding as PC became more powerful to multitasking and the multi-user type of aspects of applications, where being able to understand both sides really helped. At that time, which was the mid-80s, I started a company called Hexagon Systems in Canada, and which grew to almost 30 employees, all of them programmers working in assembler level programming. So part of the programming, which was all in assembly, of course, but also required a certain knowledge of electrical systems, which of course I carried there again into my love, which was sailing.
I think what I'll do is I'll just cut to some shots of some of the previous projects you've worked on.
Like the battery-powered electric outboard designed for Goldfish tenders in Norway. The 180 motor only weighed 110 pounds. And here's one by Campion boats. The links to the full length of these videos are in the comments below. And here is a serial hybrid motor yacht with lithium batteries designed by Pierre and Jean-Marc Zanni. For links to Jean-Marc Zanni's more recent projects with his company, see comments below.
Pierre, you put together a nice slide on the 6 points that are important to consider when you look at batteries.
Yeah, and this applies to all type of battery chemistry, whether it's lead acid or lithium ion. First one, of course, is paramount, is safety. And to be able to handle energy storage compressed, high density, to be able to, that should be done safely, and to do that you have to monitor the cell at the cell level. Number two, how do you rate different batteries? The way the automotive industry does it today is they tend to rate a battery in terms of kilowatt hour of energy per an amount of time. So in this case, it's kilowatt of energy, of power available for 1 hour would be 1 kilowatt hour. And once you find the energy density of the energy of a battery in kilowatt hour, then you look at the weight of the battery, and this is all you end up with, an energy density. So it's a kilowatt hour per kilogram. And the range is 50, 60 kilowatt hour per kilogram in terms of lead acid batteries, ranging to 3 and almost 400 watt hour per kilogram. Tesla cells are today in a range of about 320 watt hour per kilogram, I believe. Volume is the next one, which is important. So that's also a parameter that you want to look at in terms of, again, the amount of energy you're getting per volume. In this case, it's calculated in liters. Number 4 are the charge and discharge limits, and that goes back to the safety issues. If you over discharge a battery or discharge a battery too fast, it might heat up on you, and might, in case of lead acid batteries, might start boiling on you and could lead to catastrophic damage. The same applies to lithium cells, all different technology, whether you do a short on the cell itself or the pack itself, you can have some, very negative consequences. So that's why, on top of monitoring the voltage of the cells, the temperature of the cells, it's very important to also monitor at what is the charge rate and discharge rate of those battery cells. Again, completely chemistry agnostic. This applies to all type of batteries. Make sure that these charge and discharge limits are within what the manufacturer said, and these are specific to each chemistries. Then there is the voltage limits of the cell and the packs. Depending on the chemistry, again, in terms of lead acid batteries, a 2-volt battery, cannot really go below 1.5 volt per cell, and in parallel to this, you can't really charge it above 2.4 or 2.5 unless you're doing desulfating, which is the only case where you're allowed to go above that for a limited amount of time and very low amperage. But in case of lithium iron phosphate, it's around 3.2 as a maximum voltage, and around for the NMC batteries, it's more in a range of about 4.2 volt per cell. Since they're different chemistry, the voltage per cell is slightly different, and it is extremely important that these voltages, again, be respected if you want to have a safe utilization of the battery and not end up in having overcharge issues or over discharge issues.
So it's the BMS that controls that, though, isn't it?
No, it's the battery charger that you put on the battery that will control that. That's why it's important for the BMS to be able to speak to the battery charger, which is an external device, and tell the battery charger, yes, you can charge, and now you should stop charging. And some battery communications are even fancier. They will even tell a charge rate, to the battery chargers. If it's a real powerful one, tell you, okay, no, don't charge more at so many amps. And the same applies to discharging. When you're running a very big load on a battery and you're starting to crank on the amps, the amp limit should be a type of a dialogue between the BMS and the devices using the power to tell them, okay, now back off. We're putting too much power here, or start a generator to complement the draw. And so that takes care of the voltage limits. And the last one is the cell balancing. All cells, not a single cell, is built perfect. And you can't compare the cell. They're all slightly different. And what happens in a battery, if you charge all cells equally, like a lead acid battery, a 12-volt battery, where you don't have the choice because all the cells are just strung in a box and sealed, you just apply the series cell voltage on the battery itself, and you just hope that each of the cells is going to charge at the same rate. It never happens. Lead acid battery is not too bad, because once you reach maximum voltage, you just start boiling until the next cells catch up, and once you all catch up, the charging is going to stop. So it's not the end of the world, except you have to keep putting water in the cells. In the case of lithium batteries, this is not an option. You cannot ever go above the maximum cell voltage. So it's very important that there's a mechanism of both a dialogue between the battery cell / pack and the charger, so not to exceed the maximum voltage of the pack, but not either to exceed the maximum voltage per cell. That's why normally part of the balancing of the BMS, there will be at least a small resistance put on those cells which reach the higher voltage first, so that the other cells which have a bit less, so that the cells which have a little bit less energy in them are able to catch up to the cells which are already fully charged. So that's a mechanism which is also taken care of by the BMS, and a very important mechanism. How do you deal safely with energy storage? It has to be monitored. And that brings back to what I said, a few minutes ago, where, at a cell level, you want to make sure that you're monitoring the voltage and the temperatures, and also you have a table of what is acceptable and what is not. And as far as those items are concerned, that will direct the use of the battery. And also you have to have internal safety systems. It's important for the cells to be compared with one another. So if one cell for some reason has a certain voltage and another cell in the same series of cell has a different voltage, well, it shouldn't be more than so many millivolts difference. And if it starts to develop, which always does, every single cell is different, then you should have a small, balancing system that will try to equalize. The simplest one is just putting a small electrical load in the highest cell, which will bring it back in line with the one with the lower voltage. More sophisticated batteries will have small DC-DC converters that will do, active balancing, where they'll take voltage from the high cell, put it into the low cell. So, this can be as complex or as simple as you want, but it is a requirement in my book, whether you build your battery with lead acid or with lithium. All of these things should be implemented, and they are available for lead acid batteries also, as long as you're willing to buy the cells at a 2 volt level or 1.5 volt level and just build your battery using these cells.
So even with gel batteries, we had on my sailboat extra dry, we had 48 volts, and you had, even though it was AGM battery, they were being controlled for charging at the cell level.
No, they were not at a cell level, and that's why with AGM things tend to get a little bit more complicated, because you can't access, another way to monitor the cell level is to look at the acidity level in each of the cell, and that is a very good indication of the level of charge of each of the cell. And if they're not parallel, then if they're not identical or very close to it, you don't have many options because they're sealed. In the type of AGM, you can't access at a cell level.
So you were balancing the 4 different batteries.
Yes, the 4 different batteries. In this case, I went with the easiest way, and it's to have separate chargers for each of the 4 batteries. Yeah. So that I knew at least at the battery level, each of the batteries would be absolutely at the same level. And there's also another mechanism which is available in AGM, which is not available in any of the lithium chemistries, is if you keep lead acid batteries at a very high voltage, 0.3 or 0.4 volts above the maximum charging voltage, you go into anti-sulfitation mode. And that will also, because it starts to boil. So the high voltage cell will tell to boil, dissipate some energy, and then the other ones will have time to catch up. And then as soon as you stop the high voltage, the boiling stops, and all the cells are exactly the same level.
But that reduces the life of the battery.
Not really, no. They recommend doing it every 6 months or every year on all lead acid batteries, this type of desulfitation mode. It's quite an acceptable knowledge. But if somebody cares for their batteries, lead acid batteries, they can last a long time. And I should also add that if lead acid batteries were properly managed with the BMS, you wouldn't have to change them every 3 months or every 6 months, like it's happening in the charter business, like it's happening everywhere.
So if you're going to look at the required controls, you've put together some slides on the second slide there. So what are the 3 required controls then, in your mind, for batteries?
Well, the one at the top, of course, going back to the safety issue, is the fuse. Every single battery should be fused or have a fuse. If you have a series of batteries in parallel, the tendency would be to fuse the batteries in parallel also, in case one goes out of whack, So it won't, the good battery will not dump all of its energy into the bad battery to make things worse. So you have fusing in parallel, and you also have fuses in series. Very often, if the batteries are well protected and they're well controlled, meaning you know the voltage of every cell and the temperature is monitored, then having just one fuse at the end is acceptable. If you're in parallel, then, as I said, parallel and serial is required also. But so that's for the fusing level. Then when you close a contactor on a battery, you're actually doing a big voltage spike. I mean, your boat is dead, and all of a sudden it has 12, 24, or 48 volts, depending on what voltage you're using. So that voltage that voltage inrush current comes all in the same time. So the way this is dealt with, at least in the automotive industry, is by installing a pre-charge circuit. And the responsibility of that pre-charge circuit is to slowly raise the voltage up to the working voltage before the contactors are closed. So this prevents a lot of damage in electronics, especially in the high power electronics. So the pre-charge is also a system that should be implemented personally in basically all electrical systems.
Can you have a pre-charge on AGM batteries?
On everything. Like I said, all of this is absolutely battery agnostic.
Did we have pre-charge on extra dry?
Yes and no. Actually, there was a small pre-charge in your boat. I did it with just a very simple resistor, meaning that every time you put the power on, the pre-charge is there already, so the voltage slowly creeps up. It was not as critical on that vessel, that small Mirage 24.
26.
Sorry, apologize. 2 feet at that length is very important. Apologize. The reason why it was not so important is because the only 2 things that were on that 48 volt systems were a small DC-DC to give you the 12 volts for the boat, and which was not affected by the quick closing of the inrush of the current. And the second one was it was a brush motor. So as long as you're not putting any power on the motor, the power doesn't go anywhere. So it's not one that is controlled with electronics and everything else. So in that case, it was not that important to have. But I did have a very small resistor. I remember to bring the voltage.
I thought there was a pre-charge on it, and yeah. I'll have to bring out the diagrams. And perhaps I'll do a video just on the electric conversion of that boat, because you did that maybe 15 years ago, and it was really state-of-the-art at that time. And still, there are not a lot of boats of that size that are purely electric, and we had to do something, because when we bought that boat, it had a very dangerous gas engine that was not working well. And you said you're not going to have gas in this boat.
No, gas is extremely, as we said, gas is extremely dangerous.
Plus, it wasn't diesel, it was gas.
Yes, real gas engine inside the boat, which is worst case that you can get.
And it smelled like gas in the boat. So yeah. But anyways, I'm getting off topic. I put together a table so that I could make this video. I guess my first question about this table would be why you chose those 3 types of batteries for the comparison.
Just as an example. Purely example. You can select any battery manufacturer you want as long as they provide you with 2 volt cells. Most of the big manufacturers do. And then I selected the lithium iron phosphate. In this case, I picked Mercerville because they're probably one of the high volume lithium reseller for the marine market right now. And then I picked the NMC type of module, which is this type of cells used in Tesla electric cars, and most electric cars in the market today that go extremely long range will have these type of cells.
And is that the type of cell we have on BioTrek?
Yes, it is.
Okay. So let's walk through the table. People are always wondering about cost. You have 2 different cost lines. So tell us about the difference in cost. So there's the upfront cost and the amortized cost over the lifetime of the battery.
No, I didn't do any of these calculations.
But
most of these batteries, these 3 type of batteries right now, are cycles between 2,000 and 3,000 cycles, which is about 10 years of usage, if not least. So cycle life is not that much of an issue. And like I said, if the lead acid battery is well built and we push through a desulfatation cycle every 12 months, and it's not abused, overcharged, or discharged too much in this case, will last a long time. So each of these 3 batteries will certainly do the 10 years required. Where you see the costs, there are costs per unit. So when I spoke with Rolls regarding their 2 volt cells, This is the normal retail price that they have for their Rolls 2 volts battery cell, which is quite heavy, about 200 pounds per 2 volt battery. And when you go for the Master Volt, that is their retail price on the web right now for their their 5 kilowatt hour battery or 4.2 kilowatt hour battery module, which these were priced from MG Technologies in Holland, which does a really nice packaging job, a real nice safe system, safe batteries, which meets, just like Master Volt, meets 100% of the safety requirements. What I've done additionally, though, which you'll see if you start to try to come up with, understand the cost per 10 kilowatts per 10 kilowatt hour. A typical 10 kilowatt hour battery bank built with the lead acid cells would be about 520 kilos. And for those which, like they say on the web, which are, kilograms or liter adverse, it's, kilograms easy, it's multiplied by 2.2. So it's for the pound. So you're looking at that, 1,200, 1,400 pounds for a 10 kilowatt hour battery if it was built with 2 volt cells. As I said, if it's a boat that will benefit from the weight in the keel, it's not an issue. But for lighter boats where performance is a concern, that starts to be a big issue. The second item is, for example, the lithium iron phosphate is a well-known chemistry also, which is a bit older technology now. It's 130 kilos compared to 520 kilos. So it's one-third the weight. Now, if you go to even newer technology like the NMC, which is used in Tesla cars, then you're looking at another 50% cut in weight. So this is certainly one important factor. The second factor, which is important, is the amount of energy kilowatt hour per kilogram of the battery, which is also extremely important. And there again, you see almost a 50% drop between the lithium iron phosphate and the NMC type of cells. So the NMC type of cells, even though being smaller in volume, even though being lighter, they also are quite a bit more energy dense by almost a factor of 2. So these are extremely important factors when you're thinking about building a battery bank, as far as the amount of space, the amount of room you'll take in the boat, the amount of energy you'll have, and also the cost.
So Outremer installed their own batteries on the boat, and you agreed to have those batteries rather than the ones you wanted because we didn't want to delay delivery, but the decision was always to remove those batteries. And you removed them, they were brand new, and you sold them on eBay.
So to recap, in all of the batteries available, and as I said, most well-built lithium batteries, doesn't matter what chemistry they're using, are today extremely safe. So more, for me then, it becomes more a question of weight, which is, extremely important, and also cost. So we ended up going with the MG batteries for a lot of reasons, but they're extremely light, using the newer NMC type of chemistry, and have like an extremely good BMS, very well installed, built. So that's what we decided to go with the boat. So as soon as the boat was delivered, we removed the gel battery provided by the manufacturer and replaced those batteries right away by 3 of those MG Energy batteries to provide us with our 25 kilowatt hour that was a requirement.
A friend of ours, Jean-Marc Zanni, first introduced us to MG batteries and now is the U.S. distributor for MG batteries. Hello, Jean-Marc. Nice to see you by Zoom.
Nice to see you.
We were really excited to hear that they asked you to be the North American distributor. So just tell us a little bit about that.
After a quick discussion with MG, I realized that was an extremely good company with extremely reliable batteries. They wanted to expand in the North American market, and they're looking for somebody who's understood the challenges, because there are challenges with lithium batteries. They're not necessarily drop-in replacement, so you have to plan that properly. And so they want to make sure they have somebody who's capable of doing that.
So aside from being the North American distributor, are you also doing installations of those batteries?
When required, I do the basic design for the people. If the boat is local, I go in and I do help. But our main goal at this point is to develop a network of dealers. My
Okay, so
job
you
is not to do.
you help design what they need, and then they can get someone locally to follow the design and do the installation. Is that-
Exactly. Yeah.
And after visiting you, we decided to put those batteries in BioTrek, and we're so happy with them. And before that, Pierre had designed his own battery pack with Tesla batteries,
Yes.
but this was just ready to go and fit.
Turnkey.
They were turnkey, and even better is because they were so small, they fit in the space where Outremer normally puts the batteries, so we didn't require renovations.
Innovation. No, and that's the beauty of lithium compared to lead acid batteries. You can have a lot more energy for a much smaller volume and a lot less weight. And mostly in your case, like on the Ep.64, we use what we call the HE batteries, which is nickel, manganese, cobalt technology. And those are extremely light compared to any other batteries, even compared to the LFP. They are 40% lighter than LFP. And on boats where speed is not necessarily speed per se, but the boats are sensitive to weight, the fact that the batteries the energy density is much higher is very key to the success of the project.
Well, I've got another video on Jean-Marc discussing lithium batteries coming up, so the whole video will be the discussion. I hope you like this technical video all about batteries. If you have lithium batteries on your boat, we'd be delighted to hear about your installation. And please send us some comments, because we enjoy reading the comments and I try to respond when I can. I appreciate everyone who watches this video. Give us a like and subscribe.